Hello everyone, welcome to our workshop. It's topic deep dive into incident response methods. My name is Anatoly Degushin. I am digital forensics specialist at Digital Forensics and Incident Response Lab at Group AB. Today we will focus on main components of incident response, and we'll try on one of the incidents, one of the most frequently mentioned groups in ransomware, but we will talk about it a little bit later. First of all, we should deep dive into the incident response methods. So we will talk about the infrastructure preparations team. Then we will talk about the path of the way of the incident response process and the tools that could be useful for the blue teamer or incident responder. First, I would like to mention the team. It's regarding team capabilities, and I've matched it with the infinite stones from the Marvel. So this is the one of the main capabilities. One of the most important are log analysis. So we should be able to analyze firewall, proxy server, NetFlow, antivirus logs, EDR logs, Windows event logs, and other system logs, and etc. Then we should have a malware analysis capabilities. For example, we find something in PowerShell base 64 encoded, or we find some executable files and we need to analyze what's there, and we count the hash and we can find anything regarding this hash in the public CTI databases. Then we should have an endpoint digital forensics capabilities. This includes the knowledge of all operating system artifacts, and we should be able to quickly gather them and analyze them thoroughly. Afterwards, the cyber threat intelligence capabilities, they include, as I think, people who could easily find the reports or any mentions of the malware or the threat actor for each campaign. And finally, we will mention the system administrator of Windows, which is Active Directory, Unix, hypervisor, cloud, and if you have macOS, then okay, macOS system administrator. And finally, each team should have an incident or risk crisis management. Here, I mean that we should have always an incident manager, not only the incident responder. But today we will focus on first 4 or 5, maybe 4. Yes, we will have a deep dive into log analysis, malware analysis, and for digital forensics, and a little bit on cyber threat intelligence, how to use this. One of the main points of this workshop is that we won't use any customer products, just open source tools which are on freeware and can be used by any person in the world freely. Okay, so incident process lifecycle. According to the Google, I like Google's point of view the most. We have the 5 steps of the incident response. First is identification of the incident. Here I mean about detection and reporting to the incident response team. Then we talk about the coordination. Here we make the forensic triage of the victim systems and engage incident response team to analyze them. Then we focus on resolution, which means that we do investigation of the collected triage. Then after the investigation, we have the indicators of compromise and something like that. We perform containment and recovery. We eradicate the incident from our network. And finally, we do some communication in terms of public relations, law regulations, and so on. Finally, we close the incident and we do the lessons learned. So during the lessons learned, we always mean that we should enhance our security in the company. How we can do this? Either we should buy a new product, either we should replace something, either we should configure it better than it was previously. Finally, we do the continuous improvement. Here we take the lessons learned, and in case we, for example, should to deploy a new system, should buy and deploy a new system in the company, which is related to security, and it doesn't always take less than 2 weeks. It's about months or sometimes a year, for example, to change a CM system or to buy a CM system. This is always the trouble. I've mentioned indicators of compromise. Here I distinguish them on these 4 main circles. First of all is network. Here I mean IP addresses, including network ports and application protocols. Then we talk about DNS, and we talk about SSL and TLS certificates. With IP addresses and DNS, it's fine, but SSL and TLS can help us to identify whether the certificate is bad, or for example, it's Let's Encrypt if we don't trust it, and so on and so on. Infrastructure indicators of compromise means we have any compromised VPN certificates or compromised accounts, which could be the Active Directory, email, and some service accounts. Then we go to the operating system, and each operating system serves to launch the processes and the applications. So this part of the indicators are related to processes. First of all, the process has its mutex, its open ports, if it operates with over network. It has a name, and for example, if it uses SMB protocol, then it has a named pipe. For the other operating system indicators or artifacts, there are file system, which is files, directories, metadata of the files with their timestamps, names, and some other flags, which could be also useful. It could be for example, in something stored in the volume shadow copies or in alternative data stream. Then we have the registry if we talk about Windows. Registry has hives, keys, and values, which can be also useful for us. The services, this is for persistence. Then event logs, scheduled tasks, and other local accounts, and the hash sums of the files. For example, in Windows we have one artifact which stores the hash sums. It's of the executable files. It's called an cache registry hive. Then we should know what is the incident type we face. Sometimes it's about the cyber threat intelligence or the impact that we already have, or we see the attackers' lateral movement, we see their initial vector, we see the zero patient, and we try to find the main purpose of their attack. If we already discovered them by, for example, these attackers use software that via threat intelligence databases is used for money theft, then okay, we can do everything related to this. We can search for other indicators of compromise. Anyway, these incident types are listed in the pyramid, and in the lowest, in the bottom of this pyramid, we can see just the beginning of the incident, or something maybe not very dangerous or not the biggest impact, because ransomware is not the big impact when we have the good backup system. The spear phishing, or the business email compromise, of course, it's the business risk and reputation and so on, but we don't have much impact on the system. We can just clean it up, turn on the two-factor authentication, and go on. The more maybe dangerous types of incident is data leakage or data manipulation, which is now very often used by ransomware threat actors. And finally, we have the money theft and the espionage, the APT groups, which are 100% persistent. We don't even know each time what tool they were going to use. It's just a very thorough malware analysis part to find some similarities in the software used. Now we go to the analysis, and the main purpose of this phase is to perform the incident details examination. Here we get the timeline, here we get the incident scope, digital evidence acquisition and storage, and initial access vectors. So how are we going to identify the incident scope? First of all, we have the tickets from the employees or the tickets from any other driver of the incident, the information source of the incident details. And we're using cyber threat intelligence or performing some basic search in our infrastructure, find some indicators of compromise, then looking to the CDI databases and trying to find other indicators of compromise. And finally, we search throughout all endpoints using CM system, EDRs, proxy server, DNS, or manual analysis of each system. The attack model of the threat actor could be built using MITRE attack framework. It's very useful, and you know this, that we have 12 different techniques. Nowadays, it's expanded. The list is expanded a little bit about a week ago, but it doesn't matter for this particular case. So we would like to find every technique that is used and every tactic and technique used by the attacker to build its portrait and to be ready to prevent its attacks later. So now we are going to the incident, and I've already mentioned that we are going to face the ransomware, some ransomware group, and there are multiple ways how we can respond to the incident. So let's start. We see the readme txt file in the system on the desktop of our domain administrator. It doesn't matter on which computer we saw this, but we see just the personal code, and we see the input form and the website that we should open to connect to the threat actors. But of course, we don't want to do this, and we want to find any evidence of the incident, and we will try to find how the attacker gained to our infrastructure. And about our infrastructure, we had then one Active Directory domain, access to the internet, firewall. It doesn't matter on which solution firewall is based. We have the domain controller on Windows Server 2012 R2 and all 10 desktops on Windows 10 1903 and later. So it's very interesting how the incident took place, and the very important part is to mention what is the domain configurations or the group policy configuration. First of all, it's object access audit, process tracking, and account logon audit. Both, all those policies are enabled. But in this incident, we'll try to focus on that. We don't have an object access audit because in the real infrastructure, it's very difficult to enable this policy, as we will see the increase of all of the size of the security logs, and that's the big problem. What do we have to analyze the incident? We connect to the Amazon's terminal server, Windows Server with the terminal services, the remote desktop services role installed. You have your personal user and password, and you have an IP address to connect. All the files are located in the C user's desktop. I'll show it on my own desktop, and you will be able to repeat. You also have these tools, the same tools that I have during this workshop. Okay, what are the tools we are going to use? First of all, it's for forensic triage. We're not going to perform forensic triage, but it's useful to know what is that. If you don't have any EDR solutions pre-installed before the incident, and this is why when we don't have the EDR solutions installed before the incident, we won't be able to see any artifacts that it could triage tools. Then there are two main. There are CAPE and Live Response Collection. Of course, there are many other tools, like some of them that could automatically upload the triage to the Amazon or Google Cloud and automatically analyze them, but we will focus on just the CAPE. For forensic triage examination, we should have the text editors. Personally, I preserve the Notepad++ or the Sublime. If we use Windows, we can use PowerShell. And then we can use CAPE, and we can use Eric Zimmerman tools. And we have the malware samples analysis. There are reverse engineering tools, and we have the public cloud sandbox. We have CTI frameworks. So, digital forensic acquisition phase. We have the infrastructure, we have the incident. Now we are going to collect all the data to analyze it. So our incident response team engaged. It used ATT&CK, which launched CAPE to create the triage and acquire it to the Windows share on the domain controller, and all the triage data is sent to the Amazon S3. Okay, the comment, if you would like to analyze it, is it looks like in the slide. So we have the PSExec, which works from the domain administrator with the password, and it launched the CMD with the bat script. The contents of the bat script you can find on the slide. Here is the CAPE.exe with the source of the disk C, destination to the folder on the on the Windows share, and the targets. Targets are MFT, it's event logs, prefetch files, registry hives, cache, recent cache files from PowerShell console, web browsers, Skype, TeamViewer, OneDrive, Syscache, scheduled tasks, and so on. Usually we use just MFT, event logs, prefetch, registry, and sometimes scheduled tasks. Okay, now we start some practice. Let me open PowerShell, and such that I will be able to show you what's the procedure, what are the steps of the incident investigation. Just for a second, just for record, our purpose right now is to start from the from the README file, which you've seen previously in the presentation, and we would like to look at the file's metadata. So we open Timeline Explorer, and previously we should parse it with the MFT CMD file. The comment looks like as you can see on my screen. So we just change it to the rename to the DC. So if you remember, you have the same folder layout as on my screen, and we press enter. Yeah, we've got the CC output file will be saved to, and the file name. Now we should open it in the Timeline Explorer. Just press File, Open, and go to the DC. And open the latest one. Yeah, success. First, we should make our font size a little bit less, that our screen could show everything we want. We see the parent path, file name, extension, and we see the attributes of the file size, created timestamp, last modified timestamp, last record change, and last access timestamp. And also we see it's in 10 in hexadecimal counting system, and we see 30 in hexadecimal. 30 means that it's a kernel timestamps from the file name, and now it's from the file name, yes, and now there are standard info. So we will look at the created 10, and we look at the last modified and record change. Remember, we have the README file, so let's search in the file name. We type C90078 README. And click here. Yeah, we've got the file name and we've got the files extension. We can hide it, and this directory you can also hide, as we don't need those fields. We see the file size, it's not too important for us. The most important thing is the created timestamp. And let's sort by the created timestamp, and we see the 210432. it's like 9:04 UTC, 9:04 p.m. UTC on that November the 3rd, or November the 2nd, sorry. Okay, we've got this README file. Maybe the encryption process could have started earlier, and now we can check this. Now we again enable everything, and we sort by extension. We need C90078. Yep. And we've got a lot of files with this extension. Now we can also sort by created timestamp, and as you can see, it's very difficult to understand when the encryption process started, and that's the main problem, as we couldn't distinguish the encryption and the file creation, because this particular software from the ransom actors, from the threat actors, it doesn't change the timestamps. So let's maybe sort from the last record change, and now we see the timestamps, the last record change time more look like the README. As you know, README files are being created during the encryption process. So the earliest timestamp is 21:03:57, and then 21:04:13. Okay, so we now know that something started by 9:03 p.m. Let's look at the security logs. As you remember, we have the process tracking enabled in the group policy, and it's more widely spread in the organizations to enable this audit policy. So now we should open the Event Log Explorer, and at the security and system and Windows PowerShell log of the domain controller. Let me check that it's the main controller. Yes, seems so. Okay, we know that the event ID of the process creation is 4688, and we know the date and time. So let's sort these events. And unfortunately, I'm in the time zone UTC +3, and the Timeline Explorer shows the UTC time zone. So we should add into account a couple of hours. So I will create up to 1 a.m. November the 3rd, and from the November the 2nd, maybe let's go 11 or 10 p.m. Okay, we should wait some time, as the log sizes is around 1 gig. In this infrastructure, we didn't have any CM system. In the bigger organizations, of course, it usually exists, and in our installation there was no CM system, and that's why we look at each particular security event log. I've set the size to 1 GB and the default retention log policy, so we'll be able to store more events. But unfortunately, I've enabled the object audit policy, which is not true in the real infrastructures. So the event log grew up to 1 GB, but of course it will be less when you disable the object audit or just don't touch it. And just let's remember the timestamp of the beginning. It's 29:03:57. It will be 12:03 a.m. my time zone. So I hope the process is finished. Yeah, almost. Okay. So we should analyze all the events, and let me bring it up. As in the 4688 event ID, we have the new process ID, new process name, and the creator process ID. And sometimes we have the creator process name. So I see the PowerShell, and I also see the GIP AP CLI. This is Group AB TDS Hunt Point product agent installed in this on the server, and then I see the PowerShell exam from the DC account with the creator process ID 1538 in the hexadecimal format. Okay, let's look what particular process ID created the PowerShell, as it's always interesting. Then we click the sort, and now we can filter by the fields. One of the fields is new process ID, and the value, we just paste it. And click search. We'll wait for a moment. Okay, we see the three results of the search, and a couple of them are not relevant, as we should see the latest one. The latest one process is PSExec SVC. I think we can work with this. This is the PSExec, and if it's the default PSExec, it should leave some traces in the system event log, and we see the timestamp. Usually PSExec leaves 7045 events. Let's look through them. And yeah, we see the event with this particular timestamp 11:06:55 p.m. and it's in Russian, so it's 8:06 p.m. in UTC. Okay, something happened. Someone launched PSExec in this time, and we should find some traces, as it should leave the IP address of what computer launched PSExec. Let's look at the security logs. Usually we know it's 4624 event ID, logon ID 3. And let's search for the, let's clear these conditions. Now we know the timestamp will be from 11 p.m. until 12 a.m. It's 2624, or we can pass 10 p.m. Search. We see the filter result, and we need the timestamp 11:06:59. Great. We see the event. It was the logon, a logon with the account name administrator, account domain lab, from the IP address 192.168.091. And this is the lab admin PC. Now we got that. PSExec was launched from the lab administrator computer. I think we should follow this trace. Let's analyze the lab admin PC. I think we should continue with the lab admin PC. So we should repeat the same procedures with this computer. Let's start with the MFT CMD with the MFT file. Maybe we will see something. Or if you would, or in the other option, we could start analyzing event logs. Maybe let's better do this stuff. So we've opened the using file, open log file, and this standard, which is legacy. We imported 5 different event logs. Let's start from the security, as we know the timestamp 11:06:59 UTC +3, and let's look whether maybe some processes started at this moment. So we then enter 4688, and we filter date and time. 11 p.m. Okay, so this filtering stage is finished, and we see the 4688 event at 11:06:59 p.m. and let's open it up. We see the C users administrator lab admin PC, which is local admin account, desktop PSExec exe. Process name has started with this process ID, and the creator process name is cmd.exe, and this is the creator process ID. It could also be the just double click to open the CMD and then to open the PSExec, but I think we should follow this process IDs and try to identify what is the execution chain. And let's filter for the new process ID field with the value and click filter. Okay, here we've got the event of process creation. We see the new process name cmd.exe with our process ID that we've seen previously. And we've got the creator process name called cat.exe. What is this stuff? I think we should look at this sometime later. But now we would like to see who launched cat.exe. Maybe again, user did this. And we repeat the same step and filter for this value. Now again, we see that the cat.exe with the process ID has started from the CMD exe. Okay, let's make the final step to identify who launched CMD and how it was launched. Filter by the value again. And yes, the final step is that CMD exe was launched from the Explorer exe. That means that hopefully that was done by user manually. Next step is to search how, maybe when the user logged on this computer, and there are a couple of digital evidences of that. One of them is in the security event log, but it's usually difficult to look into this. And let's examine the local session manager operational event log. We need the event IDs 21 and 25, which is connection or reconnection. And yeah, it will take not much time. And we see the 10:33:06 p.m. or it's 7:33 in UTC. We've got the remote desktop services session logon succeeded from the user LabAdmin PC, which is local administrator, from the source network address 3.250.1.129 and 173. Just to analyze maybe if there is something weird in these event logs, we see that the main administrator logged on from the local interactive logon, not from the remote one. And then we previously had another logon from this source network address. And in this infrastructure, it's not possible to log on from the public IP address, just from the internal one or from the local logon when the user sits in front of the computer. And yes, you can see that 172.16.2.13 is the VPN subnet, and multiple IP addresses, if they exist here, they're from the VPN. And one another logon happened at October the 13th at 7:45 p.m. UTC. So we've got the incident timeline. The first logon took place on October 30th. That's in the same time is great, and it's not great, of course. And we should analyze maybe what other indicators of compromise or maybe files were dropped by the threat actor. When we analyzed security event log, we saw the new process name. It was the path to the file, and we saw the desktop of the local administrator. Let's go to the Timeline Explorer again and analyze what was in this folder. We again make the font size less. No, of course we didn't parse it previously, and now we should change it. PC $MFT. Okay, we see the file being created, and now we can analyze it using Timeline Explorer. We finally see it here. You see the filter applied here. We should delete it, and let's filter by the parent path, and it should be users administrator lab admin PC desktop. And we've got a lot of files. One of them is netscan psexec un.bat desktop init disable.bat catex dis.bat 333.bat and many other tools. You can find them also in the files from the triage, but for now we don't cover them. I would like you to do this in the free time if you're interested in that. Just let me say that the catex, when you will analyze it using hash sum or maybe in the sum CTI databases, this is the Mimikatz. And what we've actually got here, that the attacker launched Mimikatz to get the domain administrator password, and it used it with the pass the hash attack. We will examine it a little bit later. And we've got a lot of other files. It was a netscan, it was psexec, and if we will look at the time frame in the netscan.leak, this timestamp 21:15:46, and then if you clear the filter, and we've got this file sort by the created ones, we can find something very interesting. For example, any prefetch creation. Or we can filter by extension.pf. Here is net.exe, which means that we've launched the netscan. This is not the end of our investigation, and we should also search for any other methods that attacker used to be persistent in our infrastructure. And let's look to the PowerShell event log. Maybe we will find something. As we didn't see any encrypted files here on this host, so maybe something can happen. We opened the event log explorer and open the PowerShell event log. We can see a lot of events during this time. Maybe we can find something here. At this event type, we can see the host application string, the PowerShell command with which it has launched. We see here PowerShell execution policy bypass, no profile, no logo, no exit file, c/n.ps1. This file could be something bad, and we can examine it also. But this is the PowerShell script that starts the ransomware. Previous comments, you can see this is execution policy bypass, set MP preference, disable real-time monitoring. Unfortunately, this is the command to shut down Windows Defender, but hopefully we've got some updates that close this bug or this feature. Nevertheless, how it's named. Actually, this flag now doesn't take any effect onto the infrastructure, and Windows Defender is still working, as it now doesn't keep in mind that the registry key called disable real-time monitoring is enabled or not. So we see that the attacker tried to disable the real-time monitoring to disable the Windows Defender, and then it launched PowerShell from the psexec at the time where we've got. And if we look at the system event log, we can find some psexec routine. Just again filter to 7045. And this is the psexec. At this time, the script to encrypt all the hosts was started. As soon as we found something in the Windows PowerShell in the Windows PowerShell logs on the lab admin PC host, Let's go back to the domain controller and maybe search if there are any other commands that was launched by the PowerShell. Here we see the Windows PowerShell log, and we know now the date and time of the malicious events started, like 20:03:58. We see the ransom script started, and now we see something very interesting here at 11:13:59. This is some very big command with the base 64. And if we copy this line and try to decode it using internet, for example, I use base 64 decode. Paste our data here and press decode. And we see again something very interesting. It's again base 64 encoding, and from this base 64 string we've got some data. What we can do actually is to again copy this stuff, but I don't guarantee that we will get any interesting. We see that this is the new object input output, and we execute this stuff. You can copy it and then decode. I think we'll get something not so readable. Yeah, we see this kind of weird symbols. And from my perspective, as I'm an incident responder and endpoint digital forensics, I'm not a malware analyst. I would ask my malware analyst friend and teammate to help me to say what's here. You can pause this video for a moment and try to search by yourself. Maybe you will get some hash sums, or maybe you will find something interesting, but I see this stuff is totally encoded and obfuscated. And after the beep, you will hear the answer, what is this? Beep. And this is the Cobalt Strike. So this is the Cobalt Strike stager. Actually, it's HTTPS beacon. You should, if you will examine it more thoroughly, you could find even the IP address of the Cobalt Strike command and control server IP address. I will tell you that it's different from the IP address from which attackers logged on your system. So this is it. Let's summarize all our findings. And so after the forensic triage, we've begun the investigation on the domain controller. We've got the README files, and we've got the timestamp. Then we discovered all the process creation chains. We saw the PowerShell, which launched something. We found it was n.ps1 script, but we've got this not from the MFT file, but from the PowerShell logs. Then we've got the PowerShell was launched by PSExec SVC, and the PSExec was launched from the lab admin PC computer from the source network address 091 in the network with the privileges of domain administrator. We also tried to identify how the PSExec was launched and using what actual software. We've got this PSExec was launched from CMD. CMD was launched by the Mimikatz. Mimikatz was launched by the also CMD, which was started from the Explorer, which was done by the attacker manually after logged on our computer. This is the timestamp. So you see that 5 minutes has passed before the attacker started Mimikatz. During the initial logon time from the attacker, it copied multiple files, and some of them were started actually. One of them was network XZ which is network scan, and we've got some multiple scripts that probably was launched, probably not. Just the analysis of them will help us to identify the toolkit or the arsenal of an attacker. And also for the defense evasion, if attacker tried to shut down the Windows Defender, but it didn't work because we have an updates. And the beacon launch event ID on the domain controller was also detected, and it was the attempt to start HTTP as Cobalt Strike beacon. And also this is the event ID of the beacon launch. This is it. Thank you for your attention. Hope you liked this workshop, and if you have any questions, I think you can write me an email.